Hi, guys. I'm just going to narrate the notes from Monday in case you missed class. This way, I can explain to you what was written and it might help you understand it just a little bit better. So, on Monday, we had our first day of sequences, and sequences is really just a list of numbers. It could be letters, but we generally stick to numbers in Algebra 1. It could be something really as simple as just counting 1, 2, 3, 4, 5, 6, etc. Sequences usually have a pattern, but they don't have to. However, most of what we do will have a pattern and we will be able to write a formula. So the first examples, 1 through 6, these were just to warm you up and to see if you could figure it out. Really, we're going to do the more basic ones, but these were just to get you thinking. So for number 1, the pattern was multiplying by a -3. So to find the next 3 terms, you would just multiply by -3. Number 2, the pattern was increasing by 100. So to find the next term, you would add 100 each time. The third sequence was a little more difficult, and that is one that we would never expect you to write a formula for. It was adding the next odd number. So to go from 0 to 3, you add 3. From 3 to 8, you add 5. Then you add 7, you add 9, etc. We would not expect you to have to write that. That was just really more to have you expand your knowledge or test yourself a little bit. All right, so then number 4, the easiest way to look at that was to look at it by unreducing, the fractions. And again, this is not something we would test you on. It was just something to kind of stretch your brain a little bit. So the numerators were all increasing by 1, and the denominators were all being multiplied by 2, or powers of 2. And number 5, that was even numbers squared, starting with 2. And then number 6 was linear, increasing by 20. We would expect you to be able to figure out the patterns to sequence 1, sequence 2, sequence 6. A question like 3, 4, or 5, those would be challenged questions, and they would really just be for fun. Okay? All right, so basically the vocabulary for sequences is term. So each number in the sequence is called a term, and a term is identified by its location. So if I'm looking at sequence number 6 on my paper, 14 would be considered the first term. So we would call that the first term, or A sub 1. The 34 would be the second term, so we would call that the second term, or A sub 2. There's basically 3 ways that you can find a sequence. 2 of them have to do with formulas. We have an explicit formula, which is basically just substitution. You start with the first term, so you substitute in a 1 to find the first term, and then you substitute a 2 to find the second term, a 3 to find the third term, and so on. Recursive, this is where you can only find the next term by using the prior term. So that would be something like directions, like start with a 10 and add 7. We're not going to ask you to write recursive formulas, but we would ask you to follow directions and read them. So page 2 goes through some explicit formulas, and these you definitely have to know how to use. And it really basically is just substitution. You can actually use the y sub 1 on your calculator to get the sequence. So for the first example, which is in purple, you could type 2x minus 3 into your calculator, and then you would copy your list starting with 1, the first term. So the calculator could actually help you do anything that's explicit, but you need to make sure that you start with 1, not with 0, which is a little bit different because we're so used to starting with the y-intercept, but you would start with 1. And also, if you're using the calculator, you would replace the n with an x. Most of the time in sequences, we do use the n meaning the term number. So these are just some sequences that you can generate by substituting in a 1, then substituting in a 2, then substituting in a 3, and so on. Explicit formulas create sequences by substituting. Now, the next ones are recursive, and we're not going to test you on recursive. We're just showing you this so that you're exposed to it. A recursive formula tells you where to start and tells you what to do. So the A sub 1 tells you to start at 3, and then the formula above the recursive formula, it says times 2. So that means to find each successive number, you would multiply by 2. Then the next one says start at -2 and add 4. Then the next one says start at 81 and multiply by 1/3. So here's a little practice, and it really should just make some sense to you. You're looking at patterns. What is A sub 1? That means what's the first term? So 5. What is A sub 4? That means what's the fourth term? So 11. And then determine A sub 5. You have to go back and look at the pattern. And again, we're not going to give you very difficult patterns. We're going to give you patterns that you can probably do mentally. But again, you can always double check with your calculator. So the pattern was increasing by 2. So it was adding 2. It says multiplying, but that's not correct. It should say adding 2. So plus 2. So I'm just going to fix that for you. And then the next one, it started with a 5 and then a 2, so it was subtracting 3. Now, similar to what we were talking about in explicit, is we're going to always say things in terms of adding, so we really would say add -3 instead of subtract 3. But whatever you say in your head is absolutely fine. Okay, and then the next one is multiplying by 2. That is correct. And then again, the other one is multiplying by 2. But if you notice with the last two sequences, they had different start numbers. So they're different sequences. Okay, I hope this narration helps you. And again, you know what extra help is. You know where the room is. If you need any help, just come by.